And you can see that we have about this much left. This much left.
Okay, you guys made a big dent in your book.
Yes, right here.
Yes.
Such a hard
I read
book.
that book too. I don't remember most of it, but I read
3 more chapters, I think, 28, 29, 30, 31, 4 more chapters.
Okay. So for today in math, we will be reviewing what coefficients are. Okay. We've been working with coefficients, but we haven't exactly start labeling them. But to be able to do the next step, which is combining like terms, which is what we will be learning about today, we need to understand what a coefficient is. Okay. Can someone tell me what a coefficient is? If we can give a definition, I'm not sure. Ethan froze up. Okay. So a coefficient is the number that is in front of a variable, right? And it's being multiplied by the variable. We times it together. Okay. So I'm going to have our chat box open.
You guys don't have to mind the thing I said. I'm gonna just down to it, okay? I'm gonna write something about the math related, right? So, Kahoot, with, so, we're not gonna play that again.
Oh, yeah, if you were in on our Zoom meeting and we played it, that was Jolene, Ethan, and Claudia. You are not required to do that Kahoot again, but everyone else is. Because we did it together. But if you want to, it's good practice to try it one more time, okay? Now,
Yeah, let's do it again.
okay, so I have the chat box.
I gotta do it again because last time I sucked.
Okay, so you could do it again and try and beat your old score, yes?
I want to play it with you guys. Yes, I do.
Oh, okay. Well, right now I need to get to the warm-up, okay? So I have the chat box open. Okay, so you can type your answers in the chat box, okay? Or if you want to type it only to me, you can type it only to me. But there's some questions here. We're going to answer them in the chat box, or you can answer them out loud. But the pink one says, what is the variable of 20x squared? So what would the variable be? And we haven't worked a whole lot with exponents.
Hey, yo.
Okay, let me pause this real quick. Okay, so what is the variable for x squared? I mean 20x squared. You could put your response in the chat box. Okay. What would the variable be for 20x squared? 20. Okay, someone says 20. What is a variable?
Right. I mean, cause
I'm sorry, Ethan, you're breaking up a lot. There's a lot of static today. So I'm having difficulty hearing Ethan because there's a lot of static and the computer microphone keeps breaking up. So maybe if you could type it in, I'll be able to read it to the class. I don't know if you're too far away from the Wi-Fi connection or something.
20.
20, right? Okay. So what is a variable? Is a variable a number or a letter?
It's a letter.
It's a letter. Yeah. 20 would be the
X.
coefficient. X. Okay. So,
Can you see me now?
and then yes, it's much better. And
Okay.
what does the squared mean?
A square is 2.
2. So x times x, okay, which means that there would, there's 2 variables. There's x times x. Okay. Let's see. Going down to the next one. It says, what is the coefficient? So we have 2 times x plus 3. What would the coefficient be for the yellow one? And we were talking about this word yesterday a lot, right? Which one of these, where is the coefficient? Oh, here we go. One person says 2. Okay, so the number in front of the variable, yes, 2 would be the coefficient. Now we have 3. What is the constant? Now, we haven't talked about constant a lot. I usually say integer. 3. Yeah, the number that is not changing, right? It's constant. So 3 would be the constant. Okay, let's clear out drawings. And I'm going to scroll down a little bit because there's a couple more questions on here. Got 3 more. So how many terms do you see in 2x plus 3? How many terms are there?
What?
So the pink one, how many terms are there? When we box our terms, how many boxes are we going to have?
2 times.
Okay. So like that, 1, 2, 2 terms. Okay. And now you guys in the chat box, write down any term with the variable a. So now you make up your own with a. I want to see what you guys can come up with. Any term. So we'll have 2x is a term. You write your own, but we're using the letter a. So if I want a term with the variable a, I can say ab. I can say 3a. Okay. I could use xa times a. Okay. I could say 47a. So I need you guys to come up with an example.
From 4 and 8.
4 and 8. So 48 or just a 4 and an 8?
Yes. I'm a 4 and 8.
4 and 8. Okay. So I'm hearing 4 and 8.
Or maybe this I'm a 48.
48. Okay. And where's my variable? Because I have to use the letter A. So are you saying 48A? Like this? Because my examples in the chat box, I have 3A and I have 47A. So Ethan, are you telling me 48A? You're not using headphones. Does that make it harder to hear? Where are your headphones? Can you go get them?
Okay.
Hmm?
Okay. Okay, so it will be 48A.
Okay, 48A. And how about Jolene? Can you give me an example? And Evelyn? So I'll put an X over that one. We're not talking about that one. 6A. Thank you, Claudia. How about Jolene and Evelyn? Example of a variable with A. Are you thinking, Jolene?
Yeah.
Okay. So we have lots of examples now. We have 48A. I have 3A, XA, 47A, 6A.
48A.
48A, okay, like what Ethan said. Cool, these are all examples. They're all,
I think that 48A works.
yes, it does. Okay. And Evelyn, maybe you could help me with the next one. So write down any term with a coefficient of 5. So coefficient, that's the one where there's a number in front of a letter, right? So you guys have to come up with your own examples. And the coefficient has 5. So you could like say 5y or 5n, okay? So why don't you guys give me an example? And Evelyn, give me an example with a term that has a coefficient 5. 4n. Okay, Ethan, but we need to use the number 5, right? The coefficient is 5. 5n, okay.
How come Harry is not on this thing?
How come the what?
How come I'm a Perry is not on here?
Oh, Perry. He doesn't. He feels like he doesn't need help with math.
Really?
Oh, okay, Evelyn. So Evelyn, can you give me an example of a coefficient or a term with a coefficient of 5? Some examples are 5y and 5n.
Well, then what about Javier? I think that because Javier needs help.
Oh. Yeah, well, we're not required to join Zoom meetings, so you can always text him and ask him to join. Say, hey, you should join. We play Kahoot sometimes, or
I did, and he never replies back. Oh my God.
oh, okay. Well, we're recording this session, so you can say, hey, Perry, if you're watching, you should join math.
Hey Perry, if you're watching, you should join, and Javier too.
And Javier,
Oh, never
too.
mind. Yeah.
Yeah. Okay.
Javier has a third block, right?
Yeah, but if he's available, he could join us during second block. Okay. So let's see. All right, you know what, that's all I'm going to do today, so we can move on from that because these are lots of warm-ups. Wait, we did 2 sets. Now moving on, so coefficient again is the number that is in front of the variable. So that is what we were learning and working on yesterday. We do work with this, especially as we were solving for x and solving 1, 2, and 3-step equations. But now we're learning that this number has a name, and it is called coefficient. Okay? Now what happens when we have lots of coefficients or multiple x's, multiple variables, okay? How do we simplify that? And there is a name for that, or a phrase, we call it combining like terms, okay? So this is a video from Khan Academy, which I will put the link for. And So you can watch it again later. It's only 3 minutes, and I think they do a nice job of explaining what combining like terms means.
Let's say that you started off with 3 apples, and then I were to give you another 7 apples. So my question to you, and this might be very obvious, is how many apples do you now have? And I'll give you a second to think about that.
Okay, so if it says 3 apples plus 7 apples, how many apples do we have? How many apples would we have in total? Oh, 10, yes. Okay, so we know 3 apples plus 7 apples. Well, yeah, you would have 10 apples.
Well, this is fairly basic. You had 3 apples. Now I'm going to give you 7 more. You now have 3 plus 7. You now have 10 apples. But let's say I want to do the same type of thinking, but I'm too lazy to write the word apples. Let's say instead of writing the word apples, I just use the letter A. And I say, let's say, and this is say a different scenario, you start off with 4 apples. You start off with 4 apples, and to that, I add another 2 apples. How many apples do you now have? And instead of writing apples, I'm just going to write A's here. So
how many apples? So he's saying, I'm lazy. I don't want to write the whole word apple. I'm just going to write A. So if I have 4 apples and then I have 2 more, someone gives me 2, how many apples would I have? 6. Yes, I would have 6 apples. So he's going to explain and draw pictures to help us see how that is the same.
So how many of these A's do you now have? And once again, I'll give you a few seconds to think about that. Well, this also might be a little bit of common sense for you. If you had 4 of these apples, or whatever these A's represented, if you have 4 of them and then you add 2 more of them, you're now going to have 6 of these apples. But once again, we started off assuming that A's represent apples, but they could have represented anything. If you have 4 of whatever A represents, and then you have another 2 of whatever A represents, you'll now have 6 of whatever A represents. Or if you just think of it, if I have 4 A's, and then I add another 2 A's, I'm going to have 6 A's. You can literally think of 4 A's as A plus A plus A plus A. And if to that I add another 2 A's, so plus A, that's 2 A's right over there. How many A's do I now have? Well, that's 1, 2, 3, 4, 5, 6. I now have 6 A's. So thinking of it that way, let's get a little bit more abstract.
Before we get more abstract, so if we break it down, that's what it means, because 4 times A, there'd be 4. 1, 2, 3, 4. 2 times A would be 2. And then let me put my annotation on. The way we look at it, when we're combining like terms, I see this 4, and I also see the plus 2. So we know 4 plus 2 is 6, and then we put the A back in there. Is everyone good with it so far? Oh, no one's on screen. I can't see any thumbs up. Can you do a reaction of like hand clapping or the thumbs up if we're okay so far? Or hand? Okay, good. One person raised their hand for me. Okay. We got a chat box. Yes, good. Okay, very nice. Let me clear this, and now he's going to go to more abstract, and a lot of times that can be trickier for us to understand.
Let's say that I have 5 X's. Whatever X represents, X could be some number. So I have 5 of whatever that number is, and from that I subtract 2 of whatever that number is. What would this evaluate to? How many of these X's would I now have? So it's essentially 5X minus 2X is going to be what times X? Once again, I'll give you a few seconds to think about it. Well, if I have 5 of something and I subtract 2 of those,
Oh, sorry, I didn't pause it. What would it be? So I'm taking my 5 and I'm going to minus 2. And I'm going to remember I can do that because my x's match. Okay. So 3. -7? Okay, 3. All right, so we start at 5 and we're minusing 2. Let's see.
away, I'm going to have 3 of that something left. So this is going to be equal to 3x. 5x minus 2x is equal to 3x. And if you really think about what that means, 5x's are just x plus x plus x plus x plus x. And then we're going to take away 2 of those x's. We're going to take away 2 x's. So take away 1x, take away 2 x's. You are going to be left with 3 x's.
All right.
Before I get started defining these 5 terms, I want to describe the difference between an expression.
There we go. Okay.
Before I get started defining the.
I don't want to do that. Okay. So that was all for the introductory video. Now, let's see who is. Okay. So are we okay with combining like terms? We get the idea that the numbers that are in front of the letters, we can add and or subtract those together. One of the tricky parts is the variables have to match. We cannot do that if one letter says X and the other says Y. Okay. So let me put this back here.
To get started, suppose the variable x equals 5. Then evaluate this expression, 3x plus 4x, or click down here to review.
Okay, so it's telling us x is equal to 5. So what do we do with x being equal to 5? We're going to take our answer and we are plugging it in, right? We're switching out the x for 5 both times. So we're going to say 3 times 5 plus 4 times 5. And what does that mean? How do I simplify that further? Three times 5 is?
15.
Okay, and 4 times 5 is?
20.
20, okay. And then what's 15 plus 20? Five plus 0 is? Oh, 35, yeah. 5 plus 0 is 5, 1 plus 2 is?
3.
3, so we get 35.
Right, if x equals 5, then 3x equals 15, and 4x equals 20. So adding them together gives you 35. Now, which of these other expressions down here is equivalent to 3x plus 4x? When x equals 5, which of these also equals 35?
Okay, so taking what we saw from the other video, what can I do to find out which answer this would be? I mean, because in this example, x is equal to 5, but x could be any number, right? So what do I need to do to the coefficients? 3 and plus 4 to know that, let's see, equals, okay. So my options are 1x, 5x, 7x, and 12x. So if I'm looking at the 3 plus 4, how many x's do I need to have to make sure the answer will always match? Okay. 12x. Okay. Let's see. So let's try this. So I'm going to put my box here. And we can do it all with numbers. I could say 3 times 5 plus 4 times 5. And then I'm going to put equals 12 times 5 because we said 12x, okay? Now we're simplifying, right? 3 plus 5 we said is 15. 4 plus 5 is 20. Oops. And what is 12 plus 5? Not 12 plus 5. 12 times 5, excuse me. So we got 5 times 12 is
60.
60. Okay, going back to here. I'll put my 7. Oh, okay. Let's see. Okay, so let me finish what I was doing because I saw some other things on there. Okay, so 12 plus times 5 is 60. And then 15 plus 20 was
35.
35. And is 35 equal to 60?
No.
No, that's not equal. So can the answer be 12?
No.
No. Okay. So what I'm doing right now, what is this called when I'm putting the answers I get together?
Distribute.
Distribute. Okay. Or I said that wrong, maybe. But am I checking my work?
Yes.
Okay. So now we have the next one on there, 7x. Okay. So now I'm going to do the same thing with 7x. I'm going to get eraser. Okay. So now I have 3 times 5 plus 4 times 5 equals 7 times 5. Okay. 15 plus 20. And 7 times 5 is?
35.
35. Okay. And we said 15 plus 20 is 35. Right? Equals 35. So do they match?
Yes.
Yes, they match. So this is one way to do it. Another way I can look at it, I'm going to write this another way now. 3x plus 4x equals 7x. Okay. So when I'm looking at this and I'm combining my like terms, I'm going to circle them. So 3, I'm looking at 3 plus 4, okay? And 3 plus 4 is 7 equals 7x. So does it match that way also?
Yeah.
Okay. And the other way I can look at this as is with all the x's. So 3x means x plus x plus x, and plus 4x means 4 times now. 1, 2, 3, 4. Okay. And then we put equals, and there's 7 on the other side. So I have to write x 7 times. 1, 2, Oops. Three, 4, 5, 6, 7. Is that 7? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. So do we see the 3 ways we can look at this? I made up a number for x, a value, and I checked it and my answers matched. Okay. I took the numbers, the coefficients, and I added them together and I got 7x. Okay. If that's too abstract or confusing, I can write out all the x's and count them, because 3 and then I have 7 equals 7x. So these are all correct, and they're 3 different ways. Which one is the easiest for you to understand? Is it number 1, number 2, or number 3? Just to see where we're at. Can we type 1, 2, or 3 in our chat box so I can see which way was the easiest? 1, okay. Yeah, so when I'm solving for it and it says I'm just x and it doesn't give me an answer, I can check. I can make up my own number. I could put 5 in every single time to check it if I want to. 3, okay, yeah, physically writing out all the x's, that visual, I can do that if I need to, okay? So some people like 1, some people like 3. So this way with number 2 is still a little difficult. Let's see. Okay, so we're going to continue watching this video. After this lesson, I do have like a silly video we can watch where the guy is ordering hamburgers and he's ordering it this way. So if we were to write x's as in words, it's pretty silly. Claudia, like number 1. Okay, let me clear these. Clear all my drawings. Clear this out. Okay, so we said number 7.
Right. 3x plus 4x equals 7x. And not only is this true when x equals 5, for any value of x, 3x plus 4x always equals 7x. Let's see if we can figure out why. Well, 3x is the same as x plus x plus x, and 4x is the same as x plus x plus x plus x. Adding them together, we have a total of 7 x's here. So this equals 7 times x. No matter what x equals, 3x plus 4x equals 7x. Another way to see this is true is with the distributive law. 3x plus 4x is the same thing as x times 3 plus 4 in parentheses. If you distribute the x onto the 3 and the 4, you get 3x plus 4x. So these two expressions really are the same. And 3 plus 4 is 7. So this equals 7x. In general, you can always combine like terms. Like terms are terms that have matching variables. In this example, both terms have the same variable x. Whenever you're adding or subtracting terms with matching variables, you can combine the terms by adding or subtracting their coefficients, which are the numbers in front of the variables. So to add 3x and 4x, you can just add 3 and 4 to get 7, and then remember to include the x. Try another example. Which of these expressions is equal to 2y plus 7y?
Okay, so now I have 2 plus 7y. Is it going to be 5y, 9y, 11y, or 14y? And because a couple of people said that they like to do it with a number, I noticed it doesn't tell me what y is equal to, but I can make up a number. I can say y is equal to 2, or you can say y is equal to 5, okay? So if you need to make it equal to something, you can do that. And then plug in the numbers and solve it, okay?
Yeah.
Oh, look at everybody. I got all these 9 y's in here. Okay, that's definitely the majority I'm looking at. Okay, So I'm going to pick 9y. That's what you guys are saying.
Excellent. So for any value of y, 2y plus 7y will always equal 9y. Next, take a look at the expression b plus 5b plus b. Which of these is an equivalent expression?
Oh, that's tricky, huh? Because there's no number in front of these b's. What number do I need to put there if it doesn't tell me? If there's no number in front of the variable, what number do I put there? Let's see. 1. Okay. So I'm going to put a 1 here and a 1 there for people that need extra visuals. Okay. So if I have 1b plus 5b plus 6b, which is it going to be 2b, 5b, 6b, or 7b? Which one is my answer going to be? Or which one is the answer? I'm looking at 1 plus 5 plus 1. Okay, 7b, 7b. Okay, and after I circle those, I can also write it 1 plus 5 plus 1 equals 7, and then I put my b back on there, right? Okay, so you guys are telling me 7b?
Nicely done. When a variable is by itself, like b over here, that's the same as having 1b. So we have 1b plus 5b plus another 1b. 1 plus 5 plus 1 equals 7. So this is equivalent to 7b. For any value of b, like -6, 0, or 17, these two expressions will always give you the same result. And how about this expression, k minus 6k? Which of these expressions is equivalent?
Is it going to be 5k, -5k, 6, or -6? Put a number line on here. And I will rewrite the problem. It says k minus 6. Okay. And then what number is in front of k? The one that we can't see? 1. So my start is 1. And I'm minusing 6. Am I going to the right or to the left? If this says -6, am I going to go to the right or to the left?
To the left.
The left, okay. 6 times. So here's my 0. 1, 2, 3, 4, 5, 6. What number did I stop on?
-5.
-5. Now that is something we know how to do, right? So again, there's different ways you can do this. If you want to plug in a number like, well, I'm going to make k equal to 2, I could say 1 times 2 minus 6 times 2. And then you have to say 1 times 2 is 2. 6 times 2 is 12. And then you'd say that's -10. It's a lot more steps, okay? And then you'd say -10 equals, what number, blank number? It'd have to be -5 times 2. So then it'd be -5k. Which I feel like is confusing when we're doing it that way, okay? The other way we can do it is we can draw all the pictures and we have to X them all out, but when we get negative numbers, that can be confusing. So I like to circle the number and circle the operation, which is minus, which is 1 minus 6. And then I'll rewrite the problem to something more familiar to me, And now I'm looking at 1 minus 6, and I can do that. I'm going to take my number line, I'm going to take 1 minus 6, and I get negative 5, which means my answer is going to be negative 5, and I bring the k back. So this longer way, I get negative 5k, and the shorter way, I get negative 5k. The shortcut way. So I'm going to keep using the shortcut way so we can get more familiar with it. I feel like even if it's more confusing now, I think in the long run, and as things become more complicated, that'll be easier. All right, negative 5k.
Precisely. The coefficient of this k is 1, and 1 minus 6 equals negative 5, meaning this expression equals negative 5 times k. Next, let's look at an expression with two variables in it, 2a plus 5d. The variable a is equal to some number, but the variable d can be equal to an entirely different number. So these are not like terms. They have different variables and cannot be combined. Now, what if we were to add 6a to this expression? So now we have 2a plus 5d plus 6a. How can we simplify this expression? What's a shorter but equivalent way to write this?
Okay, so we can only add the ones that match. If they do not match, we cannot add it together. So which one do I think this might be? One thing I like to do is I like to draw circles around one. So all the A's, I'm going to put a circle on, and I have 2 A's. Okay. And then I'm going to put squares around the other variable, which is D. Okay. So now I can match my like terms. So if I'm looking at the coefficients, right? 2 plus 6, I can rewrite it. I'll rewrite it another way, okay? So I'm looking at 2 plus 6. And 2 plus 6 is?
8.
Okay, 8. I put my A back in. So now I'm rewriting my new equation. And it's saying 8A plus 5D after I clean it up. Now, can I add the 8 and the 5 together? If one says A and one says D, can I add those numbers together, or I cannot? Well, let's see. Someone said yes. So would that be like the option on there says 13 AD? Let's see what happens. Let's take a hint. Maybe it'll explain better than I am. Let me clear this. Clear my drawings. Cannot. No, we can't. Okay.
We can do this addition in any order we want. So let's combine these 2A's over here with these 6A's over here. If you do that, we'll get 8A's. There's nothing we can combine with these 5D's, so let's leave them alone. That gives us plus 5D.
Okay, so what answer do we think it is now? Because no, we cannot. Yeah, you guys are saying no, we can't do that. So this says 8A plus 5D. Does one of these answers say the same?
This one.
This one right here?
Yeah.
Okay.
Yes.
Nicely done. The like terms are 2A and 6A, and adding them together gives you 8A. Meanwhile, you can't combine 5d with any other terms, so this is the simplified expression. Now how about this one? 4x plus 9y plus 2xy minus 3y. So now we have a term with variables that are being multiplied together. How can we simplify this expression? Well, again, we look for like terms which have matching variables. First, we have 4x. Any other terms with just an x? No. 9y. Any other terms with just a y? Yes, we're subtracting 3y. So 9y minus 3y equals 6y. And then 2 times x times y. Any other terms with an x and a y? No. So this is the simplified expression. 4x plus 6y plus 2xy. So for your final challenge, take a look at this expression down here. Which of these are like terms? Which of these can you combine?
Okay, so this is called polynomials, okay? That means we have different variables, different numbers. So they have to match, the variables have to match exactly. 7 minus 3. So you're saying that, I see 1, 3 over here. So for 7 minus 3, it says AB plus BC. So do those match? Does AB match BC? Ethan? No. Okay. Okay. So we have AB. I'm just going to circle right here for now. So this does not say AB. So that's not a match. Okay. 5BA. 4AB. Okay, that one definitely matches. Yes. Now, the other tricky thing is when we multiply numbers, I guess when I said exactly, like be confusing, does it matter what order they go in? Because when we times them, we always get the same answer. Let's see what they say. So 4AB, 4AB. How about 2C? Is this a yes or a no? Yes? C matches AB? No. Okay. Crossing that one off. This one, he's probably going to check it off, but let's see. Okay, let me turn this off. So we're saying this one matches and that one matches. So 5BA, do we want to put a yes or a no on that? How many people don't know about this one? Okay, I'll put the 2 that we agreed on.
You're on the right track. 7AB and 4AB are definitely like terms. They have matching variables. But take a look at this term here, 5BA, which means 5 times B times A. Remember that when you're multiplying numbers or variables together, you can multiply them in any order. So this is the same thing as 5AB. Okay, let's put it back the way we found it, 5BA. So try this question out one more time. Select all the terms that can be combined.
Okay, so we said this one was a yes and that one was a yes. According to the video, even though the orders are switched, is 5BA also a like term?
Yes.
Okay, that's tricky. I understand.
Right, you can combine these 3 terms. Let's switch the order of the A and the B in this middle term. So to simplify, we can combine 7AB plus 5AB plus 4AB to get 16AB, because 7 plus 5 plus 4 equals 16. So this expression equals 16AB minus 3BC minus 2C.
All right, so combining like terms, did we feel great, too easy, too hard, or confusing? Did we feel this was great, too easy, too hard, or confusing?
kind of confusing for me.
Kind of confusing. Okay. So not great, but not too hard. So I'll just put confusing. Someone. Oh wait, it's not letting me do it. Oh, I know why. So it was a little confusing. Cool. Thank you for your feedback. Yeah. Okay. So we'll do a little more practicing with this. This is a new idea. The last thing I'll have us do, because our hour's up, I do have one video that's kind of funny. So I'll let us watch it. And then we'll work on some of the other stuff tomorrow. We'll continue with combining like terms tomorrow. Okay? So here is a video.
Hi, welcome to Bourbon Nation. How may I help you today?
Let me get 2 hamburgers with just pickles, 2 cheeseburgers with another cheeseburger, everything on them, 4 more hamburgers with everything, a cheeseburger with no pickles, and cheeseburger with nothing but pickles, 2 more hamburgers with everything but onions on one, everything but pickles, mustard, and tomatoes on the other, 3 large fries, 6 medium fries, 1 large fry, a junior fry, and 2 junior fries, 3 more cheeseburgers with extra cheese and bacon, 2 more junior fries, a hamburger with everything, 2 more hamburgers with everything, and 2 more hamburgers with everything, 4 large Cokes and large Sprite, 2 large Cokes and a small Sprite, 5 large Cokes and 1 large Coke and a small Coke, 3 small Cokes and a small Coke and a small Coke.
Okay, will that be everything?
Yes.
Gotcha. That's 2 hamburgers with just pickles, 2 cheeseburgers with another cheeseburger, everything on it, 4 more hamburgers with everything, a cheeseburger with no pickles, and a cheeseburger with nothing but pickles, 2 more hamburgers with everything but onions on one, and everything but pickles, mustard, and tomatoes on the other, 3 large fries, 6 medium fries, 1 large fry, a junior fry, and 2 junior fries, 3 more cheeseburgers with extra cheese and bacon, 2 more junior fries, a hamburger with everything, 2 more hamburgers with everything, and 2 more hamburgers with everything, 4 large Cokes and a large Sprite, 2 large Cokes and a small Sprite, 5 large Cokes and a small Coke, 3 small Cokes and a small Coke and a small Coke. Is that correct?
Not quite. 2 hamburgers with just pickles, 2 cheeseburgers with another cheeseburger, everything on them, 4 more hamburgers with everything, a cheeseburger with no pickles, and a cheeseburger with nothing but pickles, 2 more hamburgers with everything but onions on one, and everything but pickles, mustard, and tomatoes on the other, 3 large fries, 6 medium fries, 1 large fry, a junior fry, and 2 junior fries, 3 more cheeseburgers with extra cheese and bacon, 2 more junior fries, and a hamburger with everything, 2 more hamburgers with everything, and 2 more hamburgers with everything, 4 large Cokes and a large Sprite, 2 large Cokes and a small Sprite, 5 large Cokes and 1 large Coke and a small Coke, 3 small Cokes and a small Coke and a small Coke.
Oh, okay, that's 1 large Coke. Sorry, got it now. Is that for here or to go?
I'll have it here.
Okay, that'll be $207 even, sir.
Ooh. You know what? I only have $196 on me. I'm like $11 short.
Okay, well, if we got rid of 5 large fries and 4 large Cokes, that would be $11. Or 3 cheeseburgers and 1 small Sprite would be $11.
Okay, what about 2 large Cokes, 2 cheeseburgers, and 2 large Cokes?
No, that's $13.11.
What about 2 large Sprites, 2 cheeseburgers, and 2 large Sprites?
That would be the same.
$13?
$13.11.
All right, take off the 3 cheeseburgers and a small Sprite.
Oh, okay.
Oh, wait. So now I'm getting 2 hamburgers with just pickles, 4 more hamburgers with everything, a cheeseburger with no pickles, and a cheeseburger with nothing but pickles, 2 more hamburgers with everything but onions on one, and everything but pickles, mustard, and tomatoes on the other, 3 large fries, 6 medium fries, 1 large fry, a junior fry, and 2 junior fries, 3 more cheeseburgers with extra cheese and bacon, 2 more junior fries, and a hamburger with everything, 2 more hamburgers with everything, and 2 more hamburgers with everything, 4 large Cokes and a large Sprite, 2 large Cokes and 5 large Cokes, and 1 large Coke and a small Coke, 3 small Cokes and a small Coke.
That's correct.
Great.
Oh my God.
Listen up. Ordering 2 hamburgers with just pickles, 4 more hamburgers with everything, a cheeseburger with no pickles, and a cheeseburger with nothing but pickles, 2 more hamburgers with everything but onions on one, and everything but pickles, mustard, tomatoes on the other, 3 large fries, 6 medium fries, 1 large fry, a junior fry, and 2 junior fries, 3 more cheeseburgers with extra cheese and bacon, 2 more junior fries, and a hamburger with everything, 2 more hamburgers with everything, and 2 more hamburgers with everything, 4 large Cokes and a large Sprite, 2 large Cokes, 5 large Cokes, and 1 large Coke and a small Coke, 3 small Cokes, a small Coke, and a small Coke. Okay, that's 2 hamburgers with everything, a cheeseburger with no pickles, and a cheeseburger with nothing but pickles. 2 more hamburgers with everything but onions on one, and everything but pickles, mustard, tomatoes on the other. 3 large fries, 6 medium fries, 1 large fry, a junior fry, and 2 junior fries. 3 more cheeseburgers with extra cheese and bacon. 2 more junior fries and a hamburger with everything. 2 more hamburgers with everything, and 2 more hamburgers with everything. 4 large Cokes and a large Sprite. 2 large Cokes and 5 large Cokes, and 1 large Coke, a small Coke, and 3 small Cokes and a small Coke and a small Coke. That's correct. Coming up. How many ketchups would you like with that?
Just 1. Sure.
There you go. Good day, sir.
Thanks, you too. Man, that hit the spot. My compliments to the chef.
Compliments to the chef. Never mind. What else can I get for you today?
What do you have in the way of desserts?
Ooh, we've got apple pie and cherry pie, Boston cream pie, and brownies.
I'll have a brownie.
Okay, that's one Boston cream pie.
I said a brownie, you idiot! Can't you get a simple order right?
All right. Could that order have been done easier? Was there another way he could have made his order? Did he have to say small Coke and a small Coke and a large Coke and a small Coke? No. So if you would have combined like terms, right? So if you want 4 hamburgers with no onions, you don't have to say hamburger, no onion, hamburger, no onion, hamburger, no onion, correct? So that's why we combine like terms. So this was a silly film, but if we didn't combine and simplify, that's how our life would be. So anyways, that was just a little funny video that we could use to share. So I'm going to